this section, we're going to talk about laws associated with logarithms. But first we should talk about their domain and range. The base must be greater than 0. What you're taking the log of must be bigger than 0. C, the range, C is any real number. C is an element, the symbol is an element of, and R, the fancy written R, is the real number. C is an element of the R. That is, C is any number. C can be positive, negative, that's all I'm saying. But the A and the B must be positive. The base and what you're taking the log of must be positive. Okay, now we're ready to talk about logs. Rule number 1. And all these rules are only valid if they live up to the rules for the domain and the range. The restrictions on the A, B's, and C's that we just spoke of. For example, if you have log base A of x times y, that is log of a product, you get log of x plus log of y. The base doesn't change. Now, just in case x and y are negative, remember, what you're taking log of must be positive. Just in case x and y are both negative, well, their product will be positive. So the left side is okay. So long as A is positive and x times y is positive, we're okay. On the right side, we're okay as so far because the base is a positive. A is positive. But you know what? What we're taking log of doesn't have to be positive. It can be negative. Y can be negative. And if they're both negative, when we multiply them together on the left-hand side, they'll be positive. So if x and y are both negative, then the left-hand side of the equal sign makes sense. That is, log base A of xy makes complete sense. But the right-hand side is nonsense, because log base A of x does not make sense when x is negative, and log base A of y makes no sense when y is negative. So you can't have the left side that makes sense equaling the right side. This equal sign right there is only valid so long as the left side and the right side both make sense. Number 2. If you have log of a division, this can be equal to log of the numerator, the x, minus log of the denominator, which is y. It's not 100% if the left side equals the right side. Okay? It only makes sense if x, y, and x over y, the stuff we're taking logs of, are positive. And the left side, x over y, can be positive, or will be positive when x and y are either both positive or x and y are both negative. Problem is, on the right-hand side, they will not allow x and y to be negative. So again, the equal sign, you have to be a bit careful when you use this identity. Another rule says that if you have log base A of x to a power, you can bring that power in front. But of course, sometimes you have to be careful. For example, log base A of negative 2 to the 4th, will it equal to log base A of negative 2 with the 4 in front? The answer is no, because on the left side, we're taking log of 16, because negative 4 to the negative 2 to a 4th power gives you a positive number. On the right-hand side, we're taking log of negative 2, because that makes no sense. You can't take log of negative numbers. So, rule number 3 is iffy as well. So, we just need to be careful when we use any one of these 3 rules. Here's another rule that we should know. This is a good rule in case you need to use a calculator to calculate the log of some number. The rule basically states that if you have log base A of B and you multiply it by log base B of C, in a way the B's kind of leave, and you have log base A of C. Log base A of C. Theorem states that log base A of B times log base B of C is log base AC. Now let's see. What's probably a better form for you, or for us, is to solve this. Log base BC is equal to log base A of C divided by this, log base AB. Is that what we want? I mean, it certainly is true. Yeah, this is what we want. So notice the left side starts with B. And the only letters we have on the left side are B and C. We introduce on the right side A. Any A that we want. Any A. And the C goes on the top log, and in the denominator, the B goes there. Okay, let's look at what this is saying. Let's look at what this is saying. This is saying something very powerful, actually. In fact, let me write it down. Log base A of C divided by log base A of B. This is log base B of C. Okay. Now clear why I wrote it in that order. In fact, let's change the order. You have log base A of C divided by log base A of B. This is the same as log base B of C. So for example, if somebody asks you to calculate log base 3 of 7, well, 3 to the 1 is 3, 3 to the 2 is 9. It's somewhere in between 1 and 2. You're not going to get that unless you use a calculator. Now, on your calculator, you have a log button, which is shorthand for log base 10, and you have an ln button, which is shorthand for log base e. Those are the only two you have. So when you change the base on the left side is b. On the right side, it's whatever you want. Well, how about we choose base 10? The c stays on the top. That is, the 7 goes on the top, and the b goes in the bottom. This 3, the bottom. And there it is. Oh, on your calculator, though, it will be log 7 over divided by log 3. You don't have to say the base. If the base is 10, it's okay to not write them. Now, if for some reason you prefer the base to be letter E, instead of 10, you put E. Well, there's the 7 and this 3. Log E is shorthand to just write ln. You can change the base to whatever you want. If you find a calculator, or you're asked to write the answer with base 8, the 7 stays on the top, the base goes on the bottom. Whatever log you want. If you want log base 16, the 7's on the top and the 3's on the bottom. In your calculator, calculate this, write down the answer, calculate that, and write it down. Or, most importantly, notice that they're the same. It's the same exact answer. So we can change the base to whatever we want. Okay? Of course, if somebody asks us to find log base 3 of 9, we can do this without changing the bases. It's 2. 3 squared is 9. So if somebody asks you, log base 3 of 8, what is it equal? That is 3 to what power gives you 8? Well, I just know it's less than 2. What you can do is you can use log base 10. The 8 goes on the top, this 3 goes on the bottom. And you can calculate this in your calculator. Okay, hit the log button. It's going to open up a screen. You should hit the 8 button. You should hit the close bracket button. The right hand button. The right hand bracket. And then you should hit the division button. And then you should hit the log button. It will open up a bracket. You then hit the number 3. You then close the bracket, and then you hit the equivalent of your equal button. Okay, if you do it in this order, you'll get it correctly. Or, if for some reason you can't find the log button, or the log button is broken on your calculator, use ln. The 8 still goes on the top. This 3 still goes on the bottom. So it's ln of 8 over ln of 3. If you have a very unique calculator that gives you log base 17, well, it's log base 17 of 8 divided by log base 17 is 3. Whatever base you prefer. Whatever base you prefer. Let's see if we can think of an example where we can have a good base. We have log base 9 of 27. Well, 9 to the 1 is 9. 9, which is less than 27. 9 squared is already more than 27. What you might want, but these numbers are on powers of 3. 3 squared and 3 cubed. And if you store that, you can say log 3 logs 3 The 27 goes on the top, the 9 goes on the bottom. 3 to what power gives you 27? 3. 3 to what power gives you 9? 2. The answer is 3/2. And to convince you, I must show you that 9 to the 3/2 is 27. This is asking what times itself, in this case 2 times, gives you 9. The answer is 3. Cube that answer. And what do you know? You do get 27. You do get that answer. So sometimes, so the alternative to doing that one is you really have to grab a calculator or think about it. Okay, I definitely would not use a calculator on this problem because it takes too long to go find one. You have to turn it on, and by the time you work it out, you could have done 3 of these problems. Now, the alternative techniques on this problem is you could have what? Oh, you could have used your calculator and calculated log of 27 divided by log of 9, and believe it or not, you'll get 3/2. The other method to do this is, if you have log base 9 of 27, call it x. This means 9 to the x is 27. 9 to the x is 27. Well, 9 and 27. I want them to have the same base. I have to raise the 9 to the x and the 27 to no power. Well, 9 is 3 squared. And 27 is 3 cubed. The right-hand side is simply 3 cubed. The right-hand side, yes. The left-hand side, you multiply the 2 and the x, and that becomes the power of 3. 3 to the 2x. Well, if the bases are the same and you have equality, the powers must be equal. 2 times what gives you 3? 3 over 2. X is 3 over 2. And x we define to be log base 9 of 27. It's 3 over 2. Same answer we got earlier, sent to the bottom. Same answer we got earlier. So now, we want to write the following in longhand. That is, we don't want log of products, we don't want log of quotients, we don't want log of stuff to a power. So for example, if you had log base 7 of x times x minus 1, well, you can think of that as a or x, and that as b or y. And then you can say, well, it's log of a plus log of b. And the base doesn't change, it's 7 all around. You have log base a of a to the 17. Well, you can argue that it's 17 from right here. A to what power gives you back a to the 17th is 17. Or you can say, I can bring the 17 in front. So now I have 17 log base a of a. But this is 1. A to what power gives you back a? 1. So don't ask me why I wrote a. Gives you back 1. And 17 times 1 is 17. So we simplified it. our goal is not to have the log of a product or log of a quotient. You have log of x plus 1 divided by x minus 1. I don't care what the base is, call it C. So long as the domain stuff works out, the domains work out, these are equal. We have a log of a fraction. It's log of the numerator minus the log of the denominator. And the base stays the same. Again, if both the top and the bottom are negative, then when we divide it, it'll be positive. So this can be positive, even though that's negative, and worse yet, that's negative. That is, the left side won't equal the right side always. But so long as what you're taking log of is always positive, then they will be equal to one another. Okay, so let's look at this for a moment. Then suppose you have log of, say, AB divided by CD. I don't care what the base is. Now, if you think of this as a division, then it's log of the numerator minus log of the denominator. And thinking about that as log of the product, it's log of A plus log of B. Minus, does this, minus, thinking of log CD as log of a product, it's log of C plus log of D. So we have to take away all of that. That is, we get log of A plus log of B minus log of C minus log of D. Okay, let's see how we can get from the very beginning, log AB over CD, to the last line. Well, you have to identify the factors. The factors are the things that are being multiplied and divided. A times B divided by C divided by D. A, B, C, and D are the factors. So we're going to have log A, and we're going to have log B, and we're going to have log C, and we're going to have log D. If something's in the numerator, it becomes positive. Since A is in the numerator, it's plus log A. Since B is in the numerator, it's plus log B. Since C is in the denominator, it's minus log C. D minus log D. So, if somebody asked me for this, what's log EF over GH? Well, it's log of E plus, because F is in the top, plus log of F minus, because G is in the bottom, minus log of G, and then minus log of H, because H is in the denominator. If you can do that one, and then you can do the next one, you can do any of these. If you have the log of A to the R, B to the S, C to the T, U to the V, I meant to say D to the U, D to the U, E to the V, and F to the W. Log of that. Well, it's log of A to the R plus log of B to the S plus log of C to the T the A, the B, and the C to the T, the A to the R, the B to the S, the C to the T, they were all on the top. They all have an understood plus sign. There's an understood plus sign in front there. The other ones you had to write. Now it's minus log B to the U minus log A to the V minus log F to the W. Why were they all minus? Because they're in the denominator. Now if you were really quick, if you were exceptionally quick, what you would have done was, oh, the power can come in front. The power can come in front. The power can come in front. V and W. The power can come in front. That is, if you have log, same problem, A to the R, B to the S, C to the T over D to the U, E to the V, F to the W. It's log A to the R, where the R comes in front, plus log B to the S, the power S comes in front, plus log C to the T, the T comes in front, minus log B to the U comes in front, minus log E to the V comes in front, minus log of F, the W comes in front. Of course, there would be some base, and every log would have the same base, whatever it is. If you can do that one, you can expand any log. So, suppose somebody asks you the following problem. What is log of 2 plus log of 5? Again, this is not a time to run for a calculator. If you're running for a calculator, it's because you're not learning your rules. Because in this case, it's very straightforward. It's an addition, you multiply those, and you get log of 10. But that's easy. That's 1. Because 10 to the 1 is 10. That's why you don't run to a calculator, because you don't think. Log of A plus log of B is log of the product. Okay. Suppose you were asked to do this problem. Log base 2 of 112 minus log base 2 of 7. This is log base 2 of the division. And 7 into 112, it goes 16 times. So this is really log base 2 of 16. But that's 4. Because 2 to the 4 is 16. Okay, so we were able to do that one pretty easily. Suppose you were asked to do this. Log base 12 of 9 plus log base 12 of 16. I hope it's clear that that's a log A plus log B problem. log A plus log B. Same basis. So it's log, same base of the product. 9 times 16, I don't know, or 90 and 54, like I thought, 144. And the answer is 2, because 12 squared happens to be 144. Now, remember that A to the log base A of anything, I don't care what is there, equals that anything. A raised to the log base A of anything equals to anything. That is, A raised to the log base A of 13 is 13. So the question is, what would 10 to the log base 2 log base 10 of 3? Excuse me, that didn't work out well. Not a big deal. Just glad the last lines came out. Okay, so what would be 10 raised to the 2 log 3? Well, first, realize that log is shorthand for base 10. Now, if you have any number raised to the log of that number, of anything, anything, don't care what that is, then you get back to anything. Of course, it's understood that this is positive. Remember, log base that of this. This has to be positive. So the anything just has to be positive. And so does the base. Okay. Well, the big thing here is this is not in the form of 10 to the log base 10 or something. It's in the form of 10 raised to the 2 times log. Well, we don't want that 2. Well, let's just concentrate on this. The 2 can come up as the power. So this is 10, excuse me, this is 10 raised to the log base 10 of 3 squared. That is, it's 10 to the log base 10 of 9. So the answer is 9. Because if you have 10 to the log base 10 of anything, the answer is the anything. Or anything is 9. The answer is 9. Okay, so now I'm going to give you some expanded logs, that is the log of one thing plus 7 times the log of another thing minus 14 log of this. I want you to write it using one log. For example, the log of 7 plus the log of 13. I don't care what the base is. Base is 17. This is equal to log base 17 of, I think, 91. You multiply this 7 times 13. Multiply the 7 and 13. If I give you log base, doesn't matter, pi of 25 minus log base pi of 5, well then we get log base pi of 25 over 5, and I happen to know that division. So it's log base pi, not 10, excuse me, log base pi of 5. 25 divided by 5 is 5. And this is definitely equal, because on the left side, the base is positive, and what we're taking log of is positive. So the left side makes sense. The right side, the bases are positive, and what we're taking log of is positive. So it does turn out that the left side actually equals the middle, which equals the right-hand side. That is, in simple log form, using one log, is log base pi of 5. If you were asked to find 2 log of 3 minus 4 log of 5 plus 3 log or 6. Well, just remember the numbers in front are powers. So we're 1 log. If you have an understood plus in front, or you have a plus in front, you go on the top. Minus in front, you go on the bottom. This log has a plus in front. So I put 3 squared. I put what I'm taking log of, 3 squared. The next log, it has a minus in front. Goes in the bottom. 5 to the 4th, 625, goes in the bottom. What goes on top is 6 cubed. If I'm not mistaken, that's 216. And what is 216 times 9? Well, it's 448 times 3. That's 1200, 120, and 24. It's 1344. Minus some silly error, it's log of 1344 divided by 625. And the only numbers that goes into the bottom are 5s and powers of 5. 5 doesn't go into the top. Okay, so I took an expression that had many logs, 3 logs to be exact. I wrote it using 1 log. And if they gave you a base, like C, then every place should have C. Log of A plus log of B will not equal log of A times B. If the base associated with log A is not the same as the base associated with log B. In other words, if you have log of 7 plus log of 3, this will not equal to log of, to the log of 21 if the bases are different. If these bases are different, it's not the log of 21. And I don't care what base you put there, they won't be equal. Although I suspect you can find a base that would make it equal, some off-the-wall strange base, it would be equal. But then again, that would be very, very hard to find. But most importantly, you just can't multiply the A and the B unless the bases are the same. Suppose you had ln of A plus B plus ln of A minus B minus 7 ln's of C. Write with 1 log. Well, the A plus B goes on the top because there is an understood plus in front. What I'm taking log of, or natural log of, in the second term is A minus B. And since there's a plus in front, I put A minus B in the numerator. the 7 here is relative power. Since it's minus, I put c to its power in the denominator. And then I would simplify this one step further. A plus b times a minus b is a squared minus b squared. Either or should be acceptable. Okay. So the next set of problems, I want us to set it up so we can use a calculator to evaluate. How would we evaluate log base 5 or 7? Well, either you pick log or you pick ln. The 7 goes in the top, the 5 goes in the bottom. 7 in top, 5 in the bottom. And calculate that. In your calculator, you would hit the log button. I don't think you would hit 7 before the log, but in some calculators I wouldn't be surprised. Okay. You would hit the log button. It would prompt you with an open parenthesis. And notice I don't put the square around it because you're not pushing that button. But then you push the 7 button, and then you close the bracket, so log of 7. Then you hit the division button, and then you hit the log button. It will give you the open bracket prompt. Then you hit 5, and then you close it. And then you hit your equal or execute button, and you will find the answer with a little bit more than 1. What if you wanted log base 6 of 26? How much is that? Oh, piece of cake. Log, that is base 10, of log 26 over log 6. You'll get your answer. If you don't like logs, or maybe your log button doesn't work so well on your calculator, use ln. ln 26 over 6. That's how you would calculate that exactly using your calculator. Well, a calculator gives you an approximation usually. I mean, this answer is going to be, let's see, 6 squared. It's going to be like 1.73, but it's going to keep going. Or at least there's a good chance it'll keep going. Your calculator is not going to go on forever. And even if it did, are you going to sit there forever calculating it? And even if it tried to go on forever, of course the battery power is going to run out. Okay, so that's how you would calculate these things out with a calculator. Okay, that pretty much finishes this section. Good luck with it.